Back to my next class, we are going to be treating electrochemistry. Electrochemistry is the study of techniques that uses electrical stimulation to analyze the chemical reactivity of a system. More specifically, it analyzes the loss and the gains of electron, that is oxidation and reduction mechanism in a reaction. So you can't be talking about electrochemistry without talking about redox reaction, which is both a reduction and oxidation reaction. And so oxidation and reduction reaction is also known as redox reaction, and this provide vital information related to the kinetics, concentrations, mechanism of reaction, and chemical status of the reaction in solution. Electrochemical analysis is very helpful in many applications. There are so many areas where it is being used. One of such areas is polymerization reactions. Okay, electrochemistry is different from spectroscopy as electrochemical techniques analyze a different set of parameters. Electrochemical methods make use of electrically conductive probes or electrodes, which are usually linked to electronic devices that measure the electrical parameters of the reactant in solution. Most electroanalytical techniques use three electrodes. The electrodes are 1. Working electrode, 2. Reference electrode, and 3. The counter or auxiliary electrode. Take note. Okay, now these electrodes are connected to a potential state that control the working electrical potential and determines the resulting current. Now the working electrode, we want to look at the different electrodes now. The working electrode is a critical component of an electrochemical experiment, as this is where the key reactions take place. This electrode is usually made up of an inert material. The first step in a typical electrochemical analysis is 1. Application of a potential to the working electrode. 2. The resulting current is measured and plotted against time. Alternatively, the potential can be varied and the resulting current can be plotted against the applied potential. So we have different electrochemical techniques. We have, due to the many different combinations of working electrode types and parameters possible in electrochemical experiment, a number of techniques are possible using electrochemical principles. So some of the techniques we have are 1. Cyclic voltammetry. I'll just stop briefly on it. An electroanalytical technique that can characterize an electrochemical system. That is in this one. So it helps in experiments in determination of Nernstian or non-Nernstian behavior, rate constant, formation constant, formal potentials, and diffusion coefficients. Unfortunately, it is not a technique which is good for quantitative analysis. 2. Linear sweep voltammetry, LSV. LSV is used for quantitative electrochemical analysis. In LSV, the potential of the electrode is varied at a constant rate during the reaction, and the resulting current is measured. 3. Square wave voltammetry, used to generate 3 current potentials, which are 1. Reverse current versus potential. 2. Forward current versus potential. 3. Difference current versus potential. We have the 4th one, chronoamperometry, used to determine diffusion coefficients and investigate reaction kinetics and mechanisms. The next one we have here 4 is chronopotentiometry, used to determine higher concentration. In this technique, a constant current is applied to the electrode and the resulting potential change is plotted against time. The last one we have here is chronocoulometry. It is another version of chronoamperometry which can give a relatively more accurate measurement of a kinetic rate constant and also aids easy detection of reactants absorption on an electrode surface. So we have been able to treat some things about electrochemistry. So we'll just quickly look at the principle of potentiometry so that we can round up the principle and importance. The potential difference between the two electrodes, working electrode and reference electrode, used forms the basis of potentiometry. Working electrode and the reference electrode, take note. Potentiometry is a chemical titration technique that does not cause a color indicator. Potentiometric titration is another name for it. The method can identify an acid without using a color indicator. This technique measures the potential of the analyte with the help of electrodes. The analyte is nothing but the electrolyte solution itself. The technique uses 2 electrodes, one being the indicator, which is the working electrode I mentioned before, and the other, which is a reference electrode. The indicator electrode records the change in potential as a function of the volume of titrants added without a known concentration. The potential difference is calculated between the 2 electrodes under thermodynamic equilibrium when current flows through the electrodes. So if you want to look at the importance, so that the importance of potentiometry in analytical chemistry is 1. To determine the concentration of a solution, of a solute in a solution. It can also be used to determine the potential of the sample solution depending on the concentration of the ions. In conclusion, potentiometry or potentiometric titration is a technique in chemistry used to determine the concentration of a solution. Instead of indicators, electrodes are used. Electrodes are used to determine whether a solute is an acid or a base. The electrodes used are, we have hydrogen, we have calomel or metal. Then this technique is used widely in chemistry and pharmaceutical industries. This technique helps calculate the analyte potential and characterize the substance as an acid or a base. Of course, we know about titration even when we were in secondary school. You know, we're titrating maybe acid against a base or trying to know if it's an acid or if it's a base. So generally about titration, and we said some electrodes are being used, majorly the working electrode and the reference electrode. So we gave us 1 or 2 things about the electrodes, and we mentioned the types of electrodes that are being used: calomel, hydrogen, metal ion, etc. So I will see you in my next class where we'll be discussing protein fractionation. Bye.